Hello everyone, this is the solutions video for Codeforces Round 753, a Division 3. So, problem A, linear keyboard. In this problem, we are given a keyboard, something like A, B. This is so garbage. Okay, so yeah, so we are given a keyboard like this, right? X, Y, Z. It can be of any order, and we want to write a word. Uh, let's say hello. So what we want to calculate is whenever we write hello, we first of all click on H, then we click on E, then L, and then O. Okay, so we want to and to go from H to E, we have to go some distance. So like H to E, this is 2 distance, and then from E to L, it will be some X distance. So let's say here we have some distance D1, D2, D3. So what we want to do is calculate the sum of all these distances. So to do that, we can simply simulate it because the keyboard is just 26 large, and the word is also just 50 letters large. So we can simulate it in many ways. One is to do it in 50 times 26 times t, because what we can do is for every word, for every character of the word, we find out where its position is in the keyboard. So that would be for every character iterating the keyboard times t. T is 1000. So yeah, so this will fit. We can actually remove this lookup by using a map as well. So we can just store where the position of this character is by using a map or unordered map. Both will be pretty much same. So yeah, this is, we just have to simulate it. So an actual, for editorial, I guess I'll have to code it. So we have a string. So yeah, let's call it keyboard, and we also have the word. So in taking that as input, now we are gonna make a map, and I'm gonna call it position. This will be the lookup table for our positions. So let's iterate through all the positions, and what I'll do is positions keyboard I equals to I, right? We can just say that the position of this is 0, 1, 2, 3, and so on. Now we just have to calculate the sum, which would be the answer, let us say, and let's store the current position. The current position would be the position of the first letter, that is word 0. Now for every word, since we start from 0th word, this is given in the problem, we don't we only see this distance, and I plus plus. So the next position is position of this word I, and to the sum we will add the absolute difference between the next position and the current position, and then the current position becomes the next position for the next time, and then we can just print the answer. So let's test it. If this works, this should work. So yeah, that was it. Now the next problem, odd grasshopper. So this was an interesting problem for division 3b. In this problem, okay, let's go back to the drawing board. So in this problem, a grasshopper is at position x, right, and he can go either left or right. If he's on even number, if x is even number, he'll go to left. If he's on odd number, he'll go to right. And by how much? He goes by I, where I is the ith step. So in ith step, he will go to left if he's on even number, and right if he's on odd number, and by I steps, by I distance. So now we have to calculate where this grasshopper would be for some billions of thousand of billions, 10 to the power 14 number of steps. So how do we do this? So in this type of problem, the first thing you should do is, first of all, try to see what happens for a few of these steps and then try to make some observation out of it. So the first so initially we start from, let's say we start from 0 for simplification, right? And let's just draw the number line real quick. I hope it's understandable. So this is even. So in the first step, grasshopper would go here. Then in the second step, grasshopper would go here because it is odd now. In the third step, grasshopper would go here by 3 distance because this is also odd, will go by right. In the fourth step, we will go back to 1, sorry, not back to 0. This is 4 because we were at even. In this also even, so we will go here in the fifth step. In the sixth step, we'll go here. So if you notice something, our direction changes every time our parity changes, right? So if I was at 1, if I was at, let's say, -1, I add +2, I'm at 1, my parity is still same, so I will keep going in that direction and only move when only change direction when the parity is different. So the pattern is something like, so first we add +1. Now here we were subtracting, but let's just flip the reference. So initially we add +1, and if you see, 1 is odd number, and so if we are at even or odd, right, if we add odd to that, the parity changes. Meanwhile for even, the parity remains same. So because I added an odd number, my parity changed, and now I'm subtracting 2, then I'm subtracting 3. Now why I'm again subtracting 3? Because adding even number won't do anything to the parity, so direction remains same. But now after adding odd number, parity changes, so I change the sign. Parity didn't change because 4 is even, 5 is odd, so parity change, and so on. So we have a pattern here, right? +1, -2, -3, +4, +5, -6, -7, and so on. And we can actually add +0 here and make it consistent. So how do you solve it? Well, there are two ways. One, you can be super smart and figure out what it is, or you can simply write them down and try to find a pattern, right? And there's another cool thing, because you can see it is a pattern, right? What you can do is go to Google and type OEIS. This is the pattern finding encyclopedia, and let's just write the sum. So 0, so what would be the sum here? 0, here 1, here -1, here -4, and then 0, and then 5, right? So let's just write this 0, 1, -1. Okay, and here, as you can see, this is exactly the sequence we are looking for, and it can be defined by this function. So now let's remove this and scroll up a little bit for no reason, and now we can just code it. So it is pretty simple, but I'll code it anyways. So we have integer x and n. Now this is only for, when we start with +1. What about when we start with -1? In that also everything would remain same. It's just like multiply by -1. Here it will become negative, here it will become positive, negative, positive, negative. So yeah, I mean, after multiplying it will become like that. So, and that happens when it is even, right? When the starting position is even. So let's have this and take the input. Now keep in mind, I have this line. If you don't know what this does, I'll link a video in description which tells what it does and why you should or shouldn't have it. But yeah, that's why I don't have to worry about overflows here. You may have to if you don't use that. So now let's calculate the delta, right? So let's calculate what t would be in this equation. So this equation is basically 4 times t equals to n, right? 4 times t plus remainder equals to n. So t is n by 4 and remainder is n modulo 4. So if remainder is 0, then delta has to be 0. So let's just forget that. If remainder is 1, then delta is equals to 4 times t plus 1. Else if remainder is equals to 2, then delta is simply negative 1. Otherwise, if remainder is equals to 3, then delta is equals to negative 4 times t plus 4. So that's done. Now all we have to do is, if so this was for starting from odd position, right, the delta. When we start from even position, the delta is multiplied by negative 1, and then we just do this, right? So let's check if it works, and this does work. All right, then the next problem C, minimum extraction. So in this problem we are given an array, and what we can do is we can take an element out of this array and then subtract that element from all the other elements. So now what you have to do is, we have to tell that, we can keep doing this any number of times in any way, and we have to tell out of all those possible ways what will be the maximum minimum number. So what will be the maximum possible value of the minimum number in that array. So how do we go about this? So let's say we have this 1 6 minus 4 minus 2 minus 4. Okay, so 1 6 minus 4 minus 2 minus 4. So let's just sort it first of all, right, to think about it properly. Now here you can see that if I subtract 6, so the smaller becomes even smaller. However, if I subtract something negative, the smaller becomes bigger, right? So let's say I want this value to be the minimum value in the array, right? But regardless of everything, one thing is guaranteed, that the relative ordering doesn't change, right? Because every time we subtract something, we subtract it from all the elements, so the relative ordering never changes, right? So let's say I want this element to be the minimum element, then I have to consume these two, but I'm not sure about these two. So for this you can see, let's take a small simpler example, right? So what is this? So a1, a2 and a3, let's say I subtract a3, so it becomes like this, right? And then if I subtract this, what will happen is a2 minus a3, this will get eliminated, right? So this got eliminated, this got eliminated. Now this becomes a2 minus a3 minus a1 minus a3, and as you can see, a3 gets cancelled out and it becomes a2 minus a1. Okay, so this basically had no effect. So if you want this to be the minimum element, right, then we just want to remove all the previous elements and see what will be the minimum. So we can just run a simulation. Now there are other solutions as well, but I'll link a video where it is explained. But this is also a good solution, because now initially this was the minimum number. Now we can remove this, and this will become the minimum number, but this will become -2. Then we can remove this, and this will become -2, and then we can remove this will become 3. Then we can remove this will become 3. So 3 would be the answer. So among all the steps of the simulation, we want to find the maximum. Okay, so yeah, this is it. I can write the simulation here, scroll up for no reason. Okay, so we have n numbers, right? I'm just gonna directly store them in a multiset. If you don't know what a multiset is basically a set where multiple elements can be same. So yeah, a.insert x. Now we're just gonna keep removing from this multiset. So whatever the smallest is, that is a dot begin, right? And to okay, so to do this simulation, right, whenever we remove some element, we also have to subtract it from everything, right? But that's like, how do you do that? This will become n square. So the thing is, we don't actually have to subtract it from everything. We can just store how much we have subtracted in total, and then every time we use any element, we can subtract that. So we will call that offset. And so the smallest is not just this, but it's also offset. So initially offset is 0, but it will change. So this is the actual value, right? But we get the actual value by adding the offset. Now what we do is, let's also have an answer. So answer is negative infinity, because answer can be smaller than 0. So now answer is equals to maximum answer and smallest. So maximum, so the smallest among all the steps of the maximum of the smallest in each step is our answer, right? So that's what I'm doing here. Now the next step, what do we have to do? So we calculate this, and now we have to remove it from the multiset, right? So let's just erase a dot begin. I'm using iterator. You can just do a dot smallest or something. And smallest won't, if you write smallest, it would be wrong because it's plus offset, but you can't even write like this, otherwise it will remove all the elements that are like that. We just have to give it a pointer, iterator actually, I think. So we remove from that, and now what we have to do is offset. So offset becomes offset is something we keep adding to our value, right? So it is subtracted, so it is reduced every time we remove an element. It is reduced by this, then we can just print answer. So now, okay, so yeah, this works as well, pretty simple. All right, the next problem D, blue red permutation. So myself, I didn't solve it in the contest because I made a very stupid mistake, and that is going into stupid mode, but I'm out of it hopefully. So in this problem, we are given a bunch of numbers, right? Like -1, 2. I'm gonna write them in sorted order. They're not given in sorted order, but we can sort them without any harm because n is 2a5. So yes, this is 3, 5, 10, something like this. Now 1, 2, 3, 4, 5. So what we want to do is, we want to get a permutation. What we want to do is, we can first of all, their colors are also given. So red, blue, red, red, blue. And anything that is red, we can increase it by 1 in one step. We can do this step any number of times. So we can basically increase it as much as we want. And for blue, we can decrease it as much as we want. And what we want to do is, we want to make this into a permutation. Permutation being, 1, 2, 3, 4, 5, 1 to n in any order, not necessarily this order, but any order. So I'm gonna make the shuffling icon. Yeah, so this, and it can be shuffled. Okay, so now we have to check if it is possible to get this permutation. So you can, so there is a very straightforward solution, but before that, I think we should realize like how to reach that. So let's say that this value, what if this value was blue, right? What if this value was blue? Then we would never be able to take it to this range. So then answer obviously doesn't exist. Similarly, if this was red, we could never take it to that range, and so answer wouldn't exist. But this is not enough to figure out the solution. This is not sufficient. This is necessary for solution to exist, but it is not sufficient. And sufficiency we can probably find by trying out a lot of different things, but there is a much simpler idea here. So let's say in the end, so initially it was RB. Let's say in the end it was something like this: 2 3 4 5. Okay, let's say in the end I reshuffle I didn't reshuffle, basically. So yeah, I can put them in any order, right? And now this first represents this represents this and this. So what I'm saying is, in the final permutation, number 1 is a red number, number 2 is red number, 3 is blue, 4 is red, 5 is blue. So what I need to so yeah, this is the final configuration, let's say. Now here you can notice I can increase this number by 1 and decrease this to get this configuration as well, right? So if this is a final configuration, if this is a possible final configuration, then this is also a possible final configuration. Similarly, I can reduce this 3 to 1, this 4 to 2, and increase these to 3 and 4. So this is also a possible final configuration. So you notice that if we can do that, then we can eventually, by some number of steps, what we can do is we can get something like a number of B and then a number of R's. So yeah, and what this means is that the number 1 would be represented by this. Now they can be in any order, that doesn't matter, right? Number 1 will be blue, 2 would be blue, and so on. Let's say this K will be blue, then K plus 1 would be red, K plus 2 would be red, and N would also be red. So all the small numbers can be blue, all the big numbers can be red. So we just have to check this. Now how to check it? Let us go and I'll show the implementation. I'll code it, but to check the implementation, basically, to check it, what we want is what we want is that at number 1, right, at position, so at 1, for 1, we don't want more than 1 blue to be present, because if more than 1 blue is present, then this configuration won't be possible. Similarly, up to 2, not more than 2 blues should be present. Up to 3, not more than 3 blues, and so on. So yeah, but actually, instead of that, we can do it simply like, if we have blue, right, let's say some blue and some red. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? I forget what I said here. This is 1 2 3, this is 4 5 6, right? So we just want to check, can I make some blue 1, can I make some blue 2, can I make some blue 3, and then can I make some R4, can I make some R5, can I make some R6? And this goes for as long as many blues are there, and this goes for as long as many reds are there. So, and this we can do greedily, right? So let's say here in this case blue were 2 what were blue, 2 and 10, right? So if blue is 2 and 10, right, it is optimal to choose this to go for 1 and this to go for 10, because if this, now it can go for, no, this is also possible, right? This is also possible, but because this is, because 2 is smaller than or equal to 10, we can also, from this configuration, from this strategy, we can also reach this strategy. So switch to this strategy. So doing this greedily works. Similarly for red, what we want to see is red is at positions -1, 3 and 5. So -1, 3 and 5. So I want to move -1 to 4, 3 to 5 and 5 to 6. Okay, because what if this was 6, right? If this was 6, it couldn't be moved here. It should move here. So yeah, that is it. So to do this check, let me show you the implementation. So we make a vector, we input it, and then if you're confused why this works because of this. This is operator overloading. I basically told C++ that how to behave in case I am asking to input a vector, and this is how it behaves. So okay, and we also have string s, and now let's make two vectors, red and blue, and also let's sort it, sort a, right? And going through this vector a, if it is red, let's put it into red, otherwise let's put it into blue. Now a current number that we want to form is 1, right? So let's also iterate through blue. Now okay, so what we want is, we want that this blue I, right, we want the first blue to be this blue, the second blue to be second, the third blue to be 3. So this bi should be less, so not should be greater than or equal to current value, right? However, so let's just do it like this. Okay, so however, if it is less than, so basically if it was -1, -1 can never become 1 by decreasing it, obviously. So if it is less than current, then we cannot do it. So I'm gonna return from the function and also print no. And let's also add current plus plus. Similarly, we're gonna do for red, but for red we are gonna do from the opposite side. So r.size -1, current is n, I is greater than equal to 0, right? We're just basically iterating from opposite side of red, and current is n, I also decreases, current also decreases. And if ri is greater than current, in that case we can never form that, and we will print out no, otherwise print yes. So yeah, let's test this. Okay, did I make some mistake? Integer n, a, c in a, string, I sorted r and then b, and then if bi is less than current, then it is not possible. Print no, ri is okay. This is awkward. I is 0, current is 1. So blue have to go there, right? If pi is less than current. First of all, let's see where it is coming from. Okay, I did not think it would get. I don't know why is it not working. Okay, if si, I'm so stupid. So yeah, this should work. Okay, this is not working either. What is this? Okay, So current is that r dot size b, current is n, this is node 2, right? Okay, let's just also print I. Okay, let me just fix it real quick. At 1, let me print r. So 2 and 5. Oh, obviously I should sort after this, right? Otherwise ordering got messed up. Okay, this should work. Let's remove that. What is this? Yes, no, yes, yes, no, yes, yes. In the last one, okay, last one is no 1 or no 2. It is no 2. And where is it? 0 1 2. So no, 1 2 3 4. Print I, ri, and current. Let's print it. Interesting. Okay, obviously we just have to sort them individually, whatever. Okay, let's just sort them individually. Yeah, this works, and for the sake of sanity, I'm gonna submit and accept it. Okay, cool. Okay, finally, problem E. So what is this problem? This problem is simple actually. So we are in a n by m grid, our classic n by m grid, just like this. Okay, and this is 1 by 1. This is n by m, n comma m. So what we have to do is we are given a sequence of L, R, D, U, which basically means going left, right, down, up. And what we want to do is we want to start from one of these cells. Let's say start from here, right? And wanna follow them such that we can follow it for the most amount of time. Follow these instructions. So when can we not follow the instruction? Let's say we went here, then we went here, then we went here, then we went here. At this point we cannot follow instruction. So this was the maximum number of instructions we were able to follow, that is 1 2 3. However, if we did the same thing from here, right, so we'll go like 1 2 3 and then 4, so it would be at least 4. So this is what we have to tell. Now think about it in x and y axis. So this is how much n, this is how much m. So if at at every place, what if we store how much we have gone at maximum, not currently, but at maximum how much we have gone to the right and how much we have gone to the left. So let's say this is x and this is y. Sorry, let's say this is a and this is b. Okay, so if this a plus b plus 1, because this is where one cell we occupy when we start, if this becomes greater than m, then obviously we cannot be, we couldn't have reached this step because we would have to go out of the bounds. Similarly, let's say at this position however, let's say if this satisfied, then we can check if at this instruction we moved p maximum by upwards and q by downwards in this one cell where we were. So if this p plus q plus 1 is greater than n, then we cannot do it. So we want both of a plus b plus 1 to be less than equals to m, and p plus q plus 1 to be less than equals to n. If this is the case, right, if this is the case, then some some of this cell would definitely satisfy this. So, and what would be the cell? Well, we can simply find it by let's say we moved left by b, right, and top by p. So if we start from p plus 1 comma b plus 1, okay, this is abysmal to read. Let me go here. So if we start from p plus 1 comma b plus 1, then at maximum we will go up by p, we'll still be at 1, right, it is 1 indexed by 1, just like the question, okay, and at maximum we will go to the left, so that would be by left by b, so that would also be at 1. So in the worst case as well, we will still remain in the grid, and since we have already checked these conditions, that means for the other case, when we go to the right max and down max, we will still remain in the grid. So that would be the simple answer. And how to implement this? So for every of this every of this command, there's like 1e6 commands. For each of this command, let's store how much we have gone maximum to the left, sorry, maximum to the right and maximum to the left, and similarly how much we have gone maximum to the up and maximum to the down. We can simply just compute this, and then let's try, and the further of the instruction that we are able to do, right, the more steps we were able to perform. So let's just iterate from right, and whichever we, right, so let's say these are the instructions, so iterate from right, and whichever, let's say this, we can execute, this would be the answer. The starting position for this would be the answer. So implementation wise, it wasn't the most fun problem, but okay, let's code it. Integer n, m, and now we also have a string s, right? So how do we do this? I'm gonna store two things, okay? So like I said, the maximum I went to the right and maximum I went to the left, right? The maximum I went to the left is also the minimum I went to the right, because it is negative. Get my point? Wait, am I recording? Okay, I am recording. Yeah, would have been awkward if I was not recording. So okay, okay, so let us code this. Why is my laptop not charging? So okay, my laptop is not charging and I have only 34%. Let's code it. So let's store for x, not x, yeah, let's store for x and store for y. Now what this is, for all of this, let's have this, right, its length. So for all of those instruction positions, we're gonna store how much we can go, how much we went from starting to this ith position, how much rightmost we went, leftmost we went, topmost we went, bottommost we went. So let's have a current position. So current position is this. Now this is not current position, this is the current delta from the initial position, so that is 0 0 obviously. Now iterating over the instructions, and now if it is not the 0th one, then xi equals to xi equals to xi minus 1, yi equals to yi minus 1. This is like prefix maximum calculation, same thing really. Now if si is equals to left, then current position, this the current positions first represent the x and second represent the y, so it is like x comma y, right? And this is like x represent the minimum maximum and y also represent the minimum maximum. So if this happens, this goes by this, else if si is equals to right, then x plus plus, else if it is up, then current dot second minus minus, because this is the axis is something like this, positive x positive y. Now otherwise current dot second plus plus. Now all we have to do is we just have to update it. So xi dot first, the first represents the minimum, right? So xi dot first and current dot first. Oh, what did I do? Okay, so and this for second we are storing the maximum, so let's do the maximum. Let's do the same for our y, right? So y min max, y is stored in current dot second. So now what? Well, now let's just iterate from the opposite side, right? And we already had the equations with us. So if current dot first, sorry, if xi dot first, now for implementation purpose here, this minimum is in negative, so instead of plus we have to do minus here. So sorry, second, so this represents the maximum, this will be positive and this will be negative, so we have to do -1 +1. So this is doing the same thing, this absolute value plus this absolute value plus 1. If this is greater than m, we cannot do it. Similarly, wait, what if this happens? We are gonna continue, otherwise we definitely can. And what would be the answer? So answer would be, first of all, y, right? We first of all enter the row, so row would be yi dot second, right? The minimum basically, and then alright, and then we just return out. Otherwise we cannot do anywhere, we'll just start from 101. Okay, so let's just check this out, and wow, it passed. So let's just submit it and see if it works, and it does. Okay, cool. So these were the solutions for A to E. I wasn't able to solve F, G or H because I wasted so much time on D. I wasn't able to solve it even. It was really pathetic. But yeah, here are the what we call that, solutions. I ranked around like 2000. Pretty abysmal. Yeah, that's bad. I solved like so much time wasted on D. E was pretty simple. So yeah, hope you guys enjoyed. How can you deny this code? You should subscribe to my channel, and yeah, bye.